Okay, in this video we're going to talk about solving high-order polynomials using factoring. So the very first problem is a difference of cubes. Now I know this because I can check. The first thing you should always check for is that GCF, and notice that obviously they have no number in common and there is no variable in common, so I know immediately it's a difference of 2 cubes. Okay, so remember, to get this first binomial, you just take the cube root of what's there. So the cube root of x cubed is x. Now if you don't know the cube root of negative 343, it's not a big deal. Just pull out your calculator, go to math right here. You'll see this right here on number 4. That's the cube root. So you go 4 and you do negative 343 and then hit enter. And it tells you that it's negative 7. So I know that this is going to be x minus 7. Okay, and then we're going to build that trinomial. Remember, we do the SOPs method. That acronym tells us what to do. So it's square the first term here, so x squared. So we're going to SOPs this. The opposite sign. Okay, so this is a negative, so we're going to put a positive. The product, and when we say product, we're referring to the product of this number and variable, whatever happens to be there. So 7 times x is 7x. Sorry about that. And then plus, and this is square of the second term. So square of 7 is 49. So we're going to take our factors and set them equal to 0 like we always do. So I'm going to add 7. So x is equal to positive 7. So we have that one. This one, remember, this one rarely, if ever, factors. So why don't you just go ahead, instead of trying to figure out if it factors or not, go ahead and jump into quadratic formula and not waste your time. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And just as a reminder, remember this is a, b, and c. So the opposite of b would be negative 7 plus or minus the square root of 7 squared minus 4 times a is 1 and c is 49 all over 2 times 1. So I have negative 7 plus or minus. So I'm going to jump over to my calculator. And I have 7 squared minus, I'm going to do my parenthesis, 4 times a times c. And I get negative 147. So I have the square root of negative 147 all over 2. So I have negative 7 plus or minus. The first thing I know that I have to do is take that I out. So I'm going to bring the I out over 2. And I need to figure out what perfect square is in 147. So I'm going to go back to my calculator. I know 147 is not divisible by 2. What I do know is that 147, 7 plus 1 is 8, and 8 plus 4 is 12. So I know 147 is divisible by 3. So I'm just going to start there. So divided by 3. And 49 is a perfect square. That was just a luck, you could have started anywhere you wanted to with 16, you could have went up through your factors until you found 49. It makes no difference how you do it. Okay, so then I have 49 times 3. So I have negative 7 plus or minus. The square root of 49 is 7. Don't forget your I. Square root of 3 over 2. The last thing that you might want to do, just to make sure that you worked everything correctly, is if this is a third degree polynomial, I should have 3 answers. So I have 1 rational answer and 2 imaginary answers, which gives me those 3 solutions that I'm looking for. Okay. Number 2, exact same scenario. This is just a sum of 2 cubes. Okay, so I'm going to do the same thing. So I'm going to have a binomial, the cube root of the first term. Again, you can jump over to the calculator. I'll show you that one more time. Jump over here, hit math, and you'll see it at number 4. So let's say you don't know the cube root of 27. Oh, it's 3. So we know this is going to be 3x plus the cube root of positive 8 is positive 2. So remember, when we SOPs this. We do not SOPS the original. If you try and SOPS the original, you're going to get a bigger value. And your value shouldn't be bigger. Your exponents should not be higher than the original. They should be smaller. So this is a first degree. This should be a second degree. So we're going to square the first term. So 3x squared is 9x squared. Don't forget to square your coefficient. That's a fairly common mistake. So just make sure you square that coefficient. The opposite sign. The product of these two things, so 2 times 3x is 6x, and then plus the square of the last term, which is 4. Okay, so we're going to take our two factors, just like always, and set them equal to 0. And again, more often than not, that quadratic is not going to factor, so you might as well not even waste time. Just go ahead and jump into quadratic formula. So I have x is equal to the opposite of b plus or minus square root b squared minus 4ac all over 2a. So the opposite of b would be positive 6 plus or minus the square root 6 squared minus 4 times a times c all over 2 times 9. So I have x is equal to 6 plus or minus the square root. We can jump over to the calculator. So we have 6 squared minus parenthesis 4 times a times c. Was that a 4? Yes. Okay. Hit enter and we have negative 108. So I have negative 108 all over 18. So I know the first thing I have to do is get that I out. So I'm going to pull the I out and I need to figure out what perfect square is in 108. So because it ends in 8, I'm just going to go ahead and try to see if it's divisible by 4. It is, and this still has a perfect square of 9 in it. So I'm going to divide by 9, and now that gets me to a nice prime 3. So if 108 is divisible by 4 and 9, then 108 is divisible by the perfect square 36. Okay? So come back. I have 36 times 3. So that gives me x is equal to 6 plus or minus. Remember, square root of 36 is 6i. Don't forget your I. Square root of 3 over 18. And the last thing that you need to do is simplify your coefficients. So notice you have a 6, 6, and 18. So they're all divisible by a factor of 6. So that would be 1 plus or minus I square root of 3 over 3. 6 divided by 6 is 1. 6i divided by 6 is I. And 18 divided by 6 is 3. You can also break this apart if that helps you. You actually have to do this in college algebra, but it doesn't matter to me which way you do it. Whatever you're comfortable with, I'm totally fine with. Okay? Oh, 3. Sorry. Okay? Now this one, the first thing I'm going to check for is a GCF. They don't have a number in common. They don't have a variable in common. But notice this is that 3 term that looks like a quadratic. This term is the square of this term, and that's exactly how we're going to treat it, just like a quadratic. The only difference is instead of putting an x and an x, I'm going to have to put an x squared and an x squared, because x squared times x squared is x to the 4th. Everything else about the factoring process here is exactly the same. So I'm looking for the factors that multiply to be negative 16 and add to be negative 6. So that would be a negative 8 and a positive 2 multiplies to be negative 16, adds to be negative 6. Now these will not factor anymore. They're not the difference of two squares, so they're not going to factor. So we're just going to set those equal to 0 and solve just like we would any other statement. So I'm going to add 8. So I have x squared is equal to 8. To get rid of the square, I square root. Remember, every time you square root, you always put plus or minus. Always check to make sure that you don't have an imaginary number or a negative under your radical, and make sure that this won't simplify. So 8 isn't a perfect square, but it definitely contains a perfect square. So that would be x is equal to plus or minus 4 times 2. So x is equal to plus or minus 2 square root of 2. Okay, so this is 100% a legal, justifiable answer. One thing that I want to caution you on is to make sure you don't put the 2 in front of the plus or minus, because it is positive 2 square roots of 2 and negative 2 square roots of 2. So I'm going to subtract 2. So x is equal to negative, x squared is equal to negative 2. Square root both sides, so x is equal to plus or minus square root of negative 2. So x is equal to plus or minus I square root of 2. And again, fourth degree polynomial, 1, 2, 3, 4 answers, so I know that I'm good and done. Number 4, so again, it's a third degree, but it's not a sum or difference of cubes, so I'm wondering what I should probably do here. And notice that every single term has an x, so I can factor out that GCF of x and give me x squared plus 9x plus 14. So now this is just a regular old quadratic that we've always had. It's going to factor into 2 more binomials, so I have x and x. So I'm looking for the factors of 14 that add to be 9. So it's going to be a positive 7 and a positive 2. So I'm going to take all 3 factors. It's important to remember a third degree polynomial, 3 factors. X is equal to 0, x plus 7 is equal to 0, and x plus 2 is equal to 0. So I have x is equal to 0 is 1. So minus 7, negative 7. So it has a negative 7, so 1, 2, and then subtract 2, and I get x is equal to negative 2. So I have 1, 2, 3 zeros, and a third degree polynomial. So you always want to check those and make sure that you have is the same number of solutions as you have a degree of your polynomial.